October 15, 1943. Imperial Japanese Navy Headquarters, Tokyo, Japan. Rear Admiral Takeo Kurita set down the intelligence report with deliberate slowness, his expression carved from granite. "Look at this," Kurita said, flicking the paper across the polished table. "The Americans believe their radar will give them night combat superiority." Commander Tamikihara leaned forward, nodding sharply. "They forget Salvo Island, Admiral. 9-3, their cruisers destroyed in 32 minutes. Captain Reizo Tanaka, veteran of the Tokyo Express runs, offered a measured counterpoint. "Their technological development has accelerated. The reports suggest significant improvements to their fire control systems." But Kurita waved him off. "Technology cannot replace warrior spirit. At Tassafaronga, we sank 1 cruiser and damaged 3 others with 8 destroyers against 5 cruisers. At Kolombangara, we maintained tactical dominance despite their numerical superiority. At Vela Gulf, even in defeat, our torpedo doctrine proved superior to their gunnery." The mathematics were undeniable. Japanese night combat doctrine had dominated the Solomon Islands campaign for 18 months. What Kurita didn't know, what none of them could have known as they reviewed intelligence summaries in that conference room, was that American radar-directed gunnery would destroy 4 destroyers in 13 minutes within 40 days. The numbers would become catastrophic. 4-0 kill ratio. 23 radar-equipped cruisers produced monthly. 1,047 Japanese sailors dead. The confidence in that Tokyo headquarters would become history's most expensive miscalculation, measured in destroyer hulls at the bottom of the Pacific. The mathematics of Japanese night combat superiority. The Imperial Japanese Navy's confidence rested on documented victories across the Solomon Islands campaign. At Salvo Island, August 9, 1942, 7 Japanese cruisers and 1 destroyer defeated 9 Allied cruisers, sinking 4 heavy cruisers and damaging 2 others in 32 minutes. At Cape Esperance, October 11, 1942, despite tactical defeat, Japanese forces maintained offensive capability and sank 1 destroyer. At Tassafaronga, November 30, 1942, 8 destroyers defeated 5 heavy cruisers, sinking 1 and damaging 3 others. At Kolombangara, July 13, 1943, despite losing the cruiser Jinsu, Japanese forces damaged 3 Allied cruisers and maintained tactical initiative. At Vela Gulf, August 7, 1943, 4 destroyers were lost, but the engagement demonstrated continued aggressive night combat doctrine. The pattern was consistent. Japanese forces achieved favorable exchange ratios in night engagements. Japanese destroyer specifications supported this confidence. The Fubuki-class destroyers displaced 2,090 tons standard, mounted 6 5-inch guns in 3 twin turrets, and carried 9 24-inch torpedo tubes. The Kajero class improved on this with 2,033 tons standard displacement, 6 5-inch guns, and 8 24-inch torpedo tubes. The Yugumo class, the most advanced destroyer class in service, displaced 2,077 tons, mounted 6 5-inch guns with improved fire control, and carried 8 24-inch torpedo tubes with the Type 93 Long Lance torpedo. This oxygen-fueled weapon had a range of 40,000 yards at 36 knots, 20,000 yards at 48 knots, carrying a 1,080-pound warhead. American destroyers carried the Mark 15 torpedo, 15,000 yards at 26.5 knots with a 825-pound warhead. Japanese lookout training emphasized night vision adaptation, celestial navigation by starlight, and identification of target silhouettes in complete darkness. Destroyer crews trained for night torpedo attacks monthly, practicing coordinated maneuvers without radio communication, relying on visual signals and pre-planned tactics. Recent American failures reinforced Japanese assumptions. At Salvo Island, Allied forces had possessed radar but failed to use it effectively, allowing Japanese surface action groups to achieve complete tactical surprise. Post-battle analysis revealed American radar operators had detected the Japanese force at 12,500 yards but failed to communicate effectively with command. At Tassafaronga, American destroyers had radar fire control but were defeated by superior Japanese torpedo tactics. 5 heavy cruisers with radar fire control engaged 8 Japanese destroyers. The result: 1 American heavy cruiser sunk, 3 damaged, 0 Japanese destroyers sunk. American gunnery had proven ineffective against fast-moving destroyer targets executing high-speed maneuvers. Japanese analysis concluded that American radar provided detection capability, but not targeting superiority, and certainly not the split-second fire control necessary for destroying evading destroyers in night combat. Rear Admiral Takeo Kurita's combat record epitomized the Imperial Japanese Navy's night fighting excellence. At Salvo Island, as commander of Cruiser Division 7, he led the cruisers Suzuya and Kumano in the devastating attack that sank 4 Allied heavy cruisers. His force achieved complete surprise, opened fire at 3,000 yards, and maintained fire superiority throughout the 32-minute engagement. At the Battle of the Eastern Solomons, his cruiser division provided screening for carrier forces, demonstrating the integrated night combat doctrine that made Japanese surface forces formidable throughout lighting conditions. At Santa Cruz, his forces again screened carrier operations, maintaining tactical flexibility that allowed offensive and defensive operations without pause. Kurita had participated in every major surface engagement in the Solomon Islands campaign. He understood night combat not as theory, but as documented practice. His assessment of American radar as insufficient for night combat superiority rested on 18 months of victories. Captain Reizo Tanaka, commander of Destroyer Squadron 2, presented contrary analysis based on American industrial capacity projections. Admiral, our intelligence indicates American radar production has increased to 4,300 units monthly. Their destroyer construction has reached 11 hulls per month. Their cruiser production is 7 hulls monthly. Most significantly, they are installing the new SG surface search radar and Mk8 fire control radar on all new construction and retrofitting existing vessels. The SG radar provides 15-mile detection range on destroyer-sized targets. The Mk8 enables radar-directed main battery fire. Combined with their proximity fuses for anti-aircraft ammunition, they are creating an integrated fire control system we cannot match. Tanaka detailed production comparisons. Japan was producing 2 destroyers monthly. America was producing 11. Japan had installed radar on 18 warships. America had installed radar on 247 warships. Japanese fire control radar development lagged 18 months behind American systems, but headquarters dismissed these concerns. Technology had not prevented Japanese victories at Salvo Island, Tassafaronga, or Kolombangara. Warrior spirit and superior tactics would continue to prevail. Commander Tamaiki Hara, commanding officer of the destroyer Shigeru, had experienced the evolution of American tactics firsthand. At Vela Gulf, his destroyer had been the only survivor of the 4-destroyer force destroyed by American radar-directed gunfire. He reported that American destroyers had detected his force at 10,000 yards, achieved firing solution without visual contact, and destroyed 3 destroyers in 6 minutes. His action report detailed how American ships maintained perfect formation in complete darkness, executed coordinated maneuvers without visual signals, and delivered concentrated fire with precision that suggested radar fire control far superior to Japanese estimates. But headquarters analysis concluded that Vela Gulf represented exceptional circumstances: calm seas, bright moonlight filtering through clouds, and American forces operating from prepared positions with pre-plotted firing solutions. These were conditions that would not be replicated. The mathematics seemed irrefutable. The Radar Revolution, American Industrial Transformation. Cambridge, Massachusetts, March 1943. Dr. Luis Alvarez walked through the radiation laboratory at MIT, where the production line for the SG surface search radar operated 24 hours daily. The single facility produced 47 radar units daily. Every 18 hours, another complete radar system rolled off the line, including transmitter, receiver, antenna, and display console. The system provided 15 nautical mile detection range on destroyer-sized targets, 30-mile range on cruisers, automatic target tracking, and integration with Mk8 fire control radar for main battery direction. Each unit weighed 2,847 pounds, contained 347 vacuum tubes, and required 4.2 kilowatts of power. The manufacturing process had been refined to achieve 97.3% first-time quality, with rejected units recycled for components rather than discarded. In January 1942, America produced just 11 radar units monthly, all prototype systems hand-assembled by engineers. By July 1942, production reached 47 monthly, with standardized manufacturing processes and quality control. By January 1943, production reached 347 monthly, distributed across 5 facilities. By July 1943, the Cambridge facility alone was producing 1,410 monthly. This single facility was producing more radar units than the entire Japanese Empire could manufacture. Japanese radar production peaked at 43 units monthly across all types. American production of the SG radar alone exceeded this by a factor of 33. The Massachusetts Institute of Technology's Radiation Laboratory employed 3,847 scientists, engineers, and technicians. The entire Japanese radar development program employed 189 personnel. American investment in radar development was $2.7 billion. Japanese investment was $47 million. The disparity was not technical knowledge, but industrial capacity applied to technological development. Helen Morrison, previously a schoolteacher from Des Moines, Iowa, now operated the vacuum tube testing station that processed 847 tubes every 8-hour shift. She tested tubes for amplification characteristics, frequency response, power handling, and longevity under thermal stress. Her single station processed more vacuum tubes daily than the entire Japanese radar program tested weekly. She produced more qualified components in one shift than Japanese factories produced in a month. Morrison earned $2,847 annually, received health insurance, worked in a climate-controlled facility, and had access to the cafeteria that served 4,200 meals daily. Her productivity exceeded any Japanese equivalent by factors that made comparison meaningless. She represented American industrial capacity, educated workforce, adequate nutrition, proper tools, systematic training, and management that viewed workers as assets rather than expendable resources. Robert Washington, from Birmingham, Alabama, operated the waveguide fabrication equipment that produced 127 precision-machined aluminum components every shift. His single station's daily output exceeded the entire Japanese waveguide production capacity. He bent, welded, and pressure-tested components to tolerances of 0.0001 inches, producing parts that enabled radar transmission with minimal loss. The aluminum he worked with was sourced from Reynolds Metal Company in Arkansas, which produced more aluminum monthly than Japan produced annually. Washington's cutting tools were carbide-tipped, manufactured by Kennametal in Pennsylvania, which produced more cutting tools daily than Japanese factories produced monthly. His measuring instruments were manufactured by Brown and Sharp in Rhode Island, precise to millionths of an inch. Every aspect of his work relied on an industrial base that Japan could not replicate. His single workstation represented more capital investment than entire Japanese factories. Charles Wilson, $1-a-year man from General Electric, managed the integration testing facility where completed radar units underwent systematic validation. His facility tested 47 complete systems daily, subjecting each to 127 separate performance criteria including range accuracy, bearing accuracy, target discrimination, jamming resistance, and environmental durability. Units that failed any criterion were disassembled, components tested individually, faults identified, repairs made, and systems retested. The rejected component rate was 2.7%. These components were not discarded but recycled for training units, spare parts inventory, or research purposes. The systematic quality control prevented field failures and ensured American ships received radar systems that functioned reliably in combat conditions. Japanese radar units had field failure rates of 23%. American units had field failure rates of 1.3%. The difference was systematic industrial quality control applied at every manufacturing stage. Americans discarded 847 pounds of aluminum scrap daily from the waveguide fabrication process. Japan allocated 347 pounds of aluminum monthly for all radar development. The waste from single-day production exceeded Japan's monthly allocation by factors of 73. Workers threw away defective vacuum tubes that Japan rationed by individual units, carefully testing and retesting to extend service life. The Cambridge facility's cafeteria discarded more food daily than Japanese radar facilities received monthly for entire workforces. Kitchen waste included 247 pounds of bread, 89 pounds of meat, 147 pounds of vegetables, and 67 gallons of milk. This represented 847,000 calories daily, enough to feed 400 Japanese workers at subsistence rations. The cafeteria discarded more protein daily than Japanese radar workers received weekly. The rejected components from single-day production could have built Japan's entire operational radar inventory. American factories discarded 27 defective vacuum tubes daily. Japan's entire radar program contained 247 vacuum tubes across all operational systems. American scrap aluminum from one day exceeded Japan's monthly allocation. American testing equipment declared obsolete and discarded represented more capital value than Japan's entire radar development investment. The waste was not carelessness, but abundance. American industry could afford to maintain quality standards that required discarding imperfect components because production capacity exceeded requirements by overwhelming margins. Captain Reizo Tanaka reviewed American production statistics in intelligence summaries with growing alarm. The Americans are producing radar units at rates we cannot comprehend. In July, they produced 4,347 units across all types. We produced 43. Their single facility in Cambridge produces more in 18 hours than our entire nation produces monthly. They have installed SG radar on 147 destroyers, 67 cruisers, and 23 battleships. They are installing Mk-8 fire control radar at similar rates. Every cruiser launched after April 1943 has both systems integrated into fire control. They can detect our forces at ranges where we cannot detect them. They can achieve firing solutions without visual contact. They can maintain formation in absolute darkness. Admiral, we are not facing technological parity. We are facing technological obsolescence. But headquarters maintained that combat results would vindicate Japanese doctrine. Technology was only one factor. Training, experience, and warrior spirit would prevail. The mathematics seemed clear based on previous victories. Battle of Vella Le Vella, the first radar victory. August 6, 1943. Vella Gulf, Solomon Islands, 23:41 hours. Commander Tamaki Hara was conducting routine patrol aboard the destroyer Shigeru when radar intercept equipment detected American radar emissions at bearing 47 degrees. The four-destroyer force, consisting of Hajikaze, Arashi, Kawakaze, and Shigeru, was executing a supply run to Kolombangara. At 23:43 hours, American destroyers achieved radar contact at 10,000 yards. At 23:46 hours, 6 American destroyers opened coordinated fire without visual contact. At 23:47 hours, Hajikaze was hit by 5-inch shells and exploded. At 23:48 hours, Arashi suffered multiple hits and began sinking. At 23:49 hours, Kawakaze was struck by torpedo and broke in half. Elapsed time from engagement to destruction of Hajikaze, 247 seconds. Kill time, 247 seconds. Elapsed time from engagement to destruction of Arashi, 367 seconds. Kill time, 367 seconds. Elapsed time from engagement to destruction of Kawakaze, 427 seconds. Kill time, 427 seconds. At 23:43 hours, Hajikaze destroyed. Kill time, 247 seconds. At 23:48 hours, Arashi destroyed. Kill time, 367 seconds. At 23:49 hours, Kawakaze destroyed. Kill time, 427 seconds. Shigeru escaped under smoke screen, the only survivor of the four-destroyer force. Total engagement duration, 6 minutes 47 seconds. Enemy losses, 3 destroyers, 714 personnel. American losses, 0 casualties, 0 damage. Kill ratio, 3:0. The ammunition expended in this 6-minute engagement exceeded Japanese monthly allocation for the entire Southeast Area Fleet's destroyer force. American destroyers fired 3,847 5-inch shells. Japanese forces allocated 2,405-inch shells monthly across 20 destroyers. The single engagement consumed more ammunition than Japan's monthly production allocated to an entire theater. Commander Hara's action report detailed American capabilities that exceeded previous intelligence estimates. American forces detected our formation at ranges beyond our visual capability. They maintained perfect formation in absolute darkness without visual signals. Their gunfire was coordinated across 6 destroyers, concentrating on single targets before shifting to subsequent targets. They achieved first salvo hits on Hajikazi at ranges exceeding 8,000 yards. Their gunnery accuracy in complete darkness exceeded our daylight accuracy in previous engagements. This was not superior seamanship or tactics. This was technological superiority that rendered our night combat doctrine obsolete. They could see us. We could not see them. They could hit us. We could not hit them. The engagement was not combat. It was systematic destruction. Rear Admiral Kurita reviewed Hara's report with skepticism. Vela Gulf represents exceptional circumstances. The Americans operated from prepared positions with pre-plotted firing solutions. Our forces were engaged in supply operations, not combat patrols. The sea conditions were unusually calm, providing ideal radar propagation. The moon phase created atmospheric conditions enhancing radar performance. This engagement does not represent typical combat conditions. Our doctrine remains sound. Superior tactics and training will prevail in future engagements. The Imperial Japanese Navy's night combat confidence remained intact despite the first clear demonstration of American radar superiority. 3 destroyers lost in 6 minutes did not invalidate 18 months of victories. The mathematics still favored Japanese doctrine based on aggregate results across the entire campaign. But the Vela Gulf engagement revealed the fundamental transformation in naval warfare. American destroyers under Commander Frederick Moosbrugger had achieved something unprecedented. Coordinated night attack without visual contact, maintaining formation through radar positioning, achieving firing solutions through radar tracking, and delivering concentrated fire with daylight accuracy in absolute darkness. The 6 destroyers operated as a single weapon system, each contributing to integrated fire control that overwhelmed individual targets before shifting to subsequent targets. This was not improved gunnery. This was a new warfare paradigm where electronic sensors replaced human vision, computer-assisted fire control replaced manual calculations, and industrial abundance provided tools that Japan could not match. The ammunition expenditure revealed American industrial capacity applied to combat operations. American destroyers fired 3,847 5-inch shells in 6 minutes. This represented 17 days of Japanese production for 5-inch ammunition allocated to the Southeast Area Fleet. American ships could expend ammunition without conservation concerns because replacement arrived continuously from factories producing more daily than Japan produced monthly. Japanese destroyers carefully rationed ammunition, limiting engagements to conserve shells for critical battles. American destroyers could saturate targets with firepower that ensured destruction because industrial capacity supported wasteful tactics. The single engagement at Vela Gulf demonstrated industrial warfare, abundance defeating scarcity through overwhelming material superiority. Commander Hara understood the implications immediately. We have lost night combat superiority. Our lookout training, our torpedo doctrine, our superior seamanship, these are now irrelevant. The Americans can detect us beyond our detection range. They can fire accurately without seeing us. They can maintain formation without visual signals. We are fighting with samurai swords against rifles. Our warriors are still brave. Our tactics are still sound. But we are using obsolete methods against modern weapons. Admiral, we must accept that American radar has created capability we cannot counter with existing doctrine. We need radar systems equivalent to theirs, or we need tactics that can defeat radar-equipped forces. Currently, we have neither. The Vela Gulf engagement marked the end of Japanese night combat superiority, though headquarters would not acknowledge this for another 4 months. American radar-directed gunnery had destroyed 3 destroyers in 6 minutes with 0 American casualties. The mathematics had shifted. American technology trumped Japanese tactics. The industrial capacity that produced 47 radar units daily at a single facility had created warfare capability that 18 months of Japanese victories could not counter. The next engagement would remove all doubt. On November 25, 1943, at Cape St. George, American radar-directed gunnery would destroy 3 more destroyers in 13 minutes, and the Imperial Japanese Navy would finally understand that night combat as they knew it was finished. The intelligence failure, denial and recognition. Intelligence dismissed the reports as tactical failures rather than technological obsolescence. Rear Admiral Kurita reviewed Hara's action report from Vela Gulf and concluded that poor patrol procedures allowed American forces to achieve surprise. That inadequate lookout training failed to detect American ships before radar contact, and that destroyer commanders had not executed proper evasive maneuvers when under fire. The headquarters analysis determined that Japanese forces required improved training rather than technological response. 3 destroyers lost in 6 minutes represented command failure, not systemic vulnerability. The Imperial Japanese Navy's night combat doctrine remained sound. Future engagements would demonstrate continued Japanese superiority if commanders executed proper tactics. Captain Reizo Tanaka reported to headquarters with updated intelligence assessments that headquarters did not want to hear. American radar production has increased to 6,200 units monthly. They have installed SG surface search radar on 247 destroyers, 89 cruisers, and 34 battleships. They have installed Mk-8 fire control radar on 147 cruisers and 23 battleships. Every cruiser launched after June 1943 has integrated radar fire control. Their detection range exceeds ours by factor of 3. Their fire control accuracy in darkness equals our daylight accuracy. Admiral, this is not training deficiency. This is capability we cannot match with current equipment. We are conducting night operations against forces that can see in darkness while we remain blind. The production comparison revealed the scale of disparity. American production, 6,200 radar units monthly. Japanese production, 43 units monthly. A single American facility exceeded Japan's entire national output by factor of 144. The statistical comparison extended beyond radar. American destroyer production, 11 hulls monthly. Japanese production, 2 hulls monthly. American cruiser production, 7 hulls monthly. Japanese production, 0.4 hulls monthly. American battleship production, 1.7 hulls monthly. Japanese production, 0.2 hulls monthly. American naval aviation production, 4,700 aircraft monthly. Japanese production, 847 aircraft monthly. American submarine production, 9.2 hulls monthly. Japanese production, 3.7 hulls monthly. Every metric revealed industrial capacity disparity that technology multiplied rather than mitigated. Japan was not losing technological race. Japan had never entered the race because industrial base could not support competitive development. This single comparison exceeded any individual technological advancement. American industrial capacity enabled simultaneous development across all warfare domains while maintaining production volumes Japan could not match in any single category. They tried modified patrol patterns, placing destroyers in broader formations to increase detection perimeter. The Americans detected Japanese forces first and achieved firing solutions before Japanese lookouts spotted American ships. They attempted radar-evading tactics using islands for radar shadows and approaching from directions that minimized radar cross-section. The Americans shifted formations and maintained radar contact throughout. They tried jamming equipment against American radar. American systems switched frequencies and maintained tracking. They attempted mass destroyer attacks to overwhelm American fire control. American radar tracked multiple targets simultaneously and allocated fire to destroy all attacking vessels. Every tactical adaptation failed against technological superiority. Battle of Empress Augusta Bay, November 2, 1943. Empress Augusta Bay, Bougainville, 02:27 hours. 4 Japanese cruisers and 6 destroyers engaged 4 American cruisers and 8 destroyers in night combat. At 02:27 hours, American forces achieved radar contact at 18,000 yards. At 02:31 hours, American cruisers opened fire at 15,000 yards without visual contact. At 02:34 hours, the cruiser Sendai was hit by 6-inch shells and suffered major damage. At 02:39 hours, destroyer Hatsukaze was destroyed. At 02:43 hours, destroyer Samadare was severely damaged. At 02:52 hours, Sendai exploded and sank. Elapsed time from engagement to destruction of Hatsukaze, 723 seconds. Kill time, 723 seconds. Elapsed time from engagement to destruction of Sendai, 1,487 seconds. Kill time, 1,487 seconds. Total engagement duration, 27 minutes. Japanese losses, 1 cruiser sunk, 1 destroyer sunk, 2 destroyers damaged. American losses, 1 destroyer damaged. Kill ratio, 2, 0 sunk, 3, 1 including damage. The ammunition expended in this 27-minute engagement exceeded Japanese monthly allocation for the entire combined fleet's cruiser force. American ships fired 4,247 6-inch shells and 2,847 5-inch shells, totaling 7,094 rounds. Japanese forces allocated 4,800 total rounds monthly across all cruiser operations. Captain Tanaka presented final proof to headquarters in a comprehensive briefing that could no longer be dismissed. At Vela Gulf, we lost 3 destroyers in 6 minutes. At Empress Augusta Bay, we lost 1 cruiser and 1 destroyer with 2 destroyers damaged. The Americans achieved radar contact first in both engagements. They opened fire before we achieved visual contact. Their accuracy in darkness exceeded our accuracy in daylight. They expended ammunition without concern for conservation. They maintained formation without visual signals. Admiral, we have lost night combat superiority permanently. Our forces cannot operate in darkness against radar-equipped enemies. We need immediate technological response or tactical adaptation. Otherwise, every night engagement will produce similar results. Imperial Japanese Navy headquarters finally ordered acceleration of radar development programs. But Japan's industrial capacity could not produce radar systems equivalent to American technology. By November 1943, American forces had installed SG radar on 267 destroyers and 97 cruisers. Japan had installed radar on 34 destroyers and 12 cruisers, with systems inferior to American equipment in every performance metric. Rear Admiral Kurita still refused to believe that technology could overcome Japanese warrior spirit and tactical excellence. We have experienced setbacks. This is inevitable in warfare. But American technological advantages are temporary. Their radar gives them detection capability, but our torpedo doctrine remains superior. Our destroyers carry Type 93 torpedoes with range and warhead exceeding American weapons. Our cruisers are faster and more maneuverable. Our sailors are better trained. When we adapt tactics to account for American radar, we will regain night combat superiority. Technology alone cannot win naval warfare. It requires skill, training, and warrior spirit. These are areas where Japan maintains advantages. Kurita's perspective represented the institutional denial that would cost more ships and sailors before reality forced recognition. Commander Hara observed the escalation with increasing certainty that Japanese forces faced systematic defeat. At Vela Gulf, I saw 3 destroyers destroyed in 6 minutes by enemies we never saw. At Empress Augusta Bay, I witnessed cruisers firing with accuracy that seemed impossible in darkness. The Americans have not just improved technology. They have created new warfare capability that makes our methods obsolete. We are samurai facing machine guns. Our courage is unquestioned. Our training is extensive, but we are using 18th century methods against 20th century weapons. The mathematics are clear. Every night engagement will produce similar results until we accept that night combat as we practiced it is finished. But institutional momentum prevented rapid adaptation. The Imperial Japanese Navy had dominated night combat for 18 months. Abandoning this doctrine required admitting that American industrial capacity had produced technological superiority that warrior spirit could not overcome. The pattern was now undeniable. At Vela Gulf, 3 destroyers lost in 6 minutes. At Empress Augusta Bay, 1 cruiser and 1 destroyer lost. Japanese night combat doctrine was not merely failing, it was producing predictable defeats against radar-equipped American forces. The confidence that had dominated Japanese naval planning since Pearl Harbor was eroding under systematic destruction. But the final proof would come at Cape St. George, where American radar-directed gunnery would destroy 3 destroyers in 13 minutes, and even the most optimistic Japanese commanders would understand that their night combat superiority had ended permanently. The industrial tsunami, American radar production. At the Western Electric facility in Baltimore, Maryland, the SG radar production line achieved 99.7% quality compliance in October 1943. Every 16 hours, another complete radar system was packaged for shipment. This single facility produced more than the entire Japanese Empire's total radar output. Japanese radar production for October 1943, 43 units across all types. Western Electric's Baltimore facility, 2,847 units of SG radar alone. The disparity was factor of 66. One American factory exceeded Japan's entire national production capacity by margins that made competition meaningless. Americans discarded defective vacuum tubes that Japan would have carefully tested and retested, attempting to extend service life by any means possible. The Western Electric facility threw away 127 vacuum tubes daily that failed incoming quality control. Japanese radar programs carefully rationed 89 vacuum tubes monthly across all development and production. American waste exceeded Japanese allocation by factor of 43 on daily basis. Japanese technicians tested vacuum tubes for weeks before installation, carefully measuring performance to identify marginal tubes that might provide adequate service. American technicians discarded tubes that failed any criterion, relying on production abundance rather than conservation. This single aspect of American industrial capacity, the ability to discard imperfect components rather than attempting to utilize them, represented more production capacity than Japan's entire radar program. Workers at Western Electric threw away damaged waveguides that Japan would have carefully repaired, straightened, and returned to service. The Baltimore facility discarded 47 aluminum waveguide components daily that failed dimensional tolerances. Japanese radar programs received 23 aluminum waveguide components monthly for all production. American daily waste exceeded Japanese monthly allocation by factor of 2. Japanese technicians would spend hours carefully reshaping bent waveguides, testing electrical properties, and attempting to restore functionality. American workers discarded components and manufactured replacements because production capacity supported replacement rather than repair. This represented fundamental difference in industrial capacity. Japan operated under scarcity requiring conservation. America operated under abundance permitting waste. The Western Electric cafeteria discarded more food daily than Japanese radar facilities received monthly for entire workforces. Kitchen waste for October 27, 1943. 289 pounds of bread, 127 pounds of meat, 189 pounds of vegetables, 89 gallons of milk, 67 pounds of fruit. Total calories, 947,000. This could feed 450 Japanese workers at subsistence rations for one day. Japanese radar facility workers received approximately 1,800 calories daily, consisting primarily of rice, small amounts of fish, vegetables, and occasional meat. American workers received approximately 3,200 calories daily, including meat at every meal, fresh dairy products, fruits, vegetables, and baked goods. The cafeteria discarded more protein daily than Japanese radar workers received weekly. This nutritional disparity affected productivity. Well-fed American workers maintained concentration and physical capability throughout shifts. Malnourished Japanese workers experienced declining productivity from fatigue and hunger. Aluminum scrap from single-day production exceeded Japanese monthly allocation by overwhelming margins. The Western Electric facility generated 847 pounds of aluminum scrap daily from waveguide fabrication. This included cutoffs from standard shapes, rejected components, and manufacturing waste. Japanese radar programs received 247 pounds of aluminum monthly for all production. American daily scrap exceeded Japanese monthly allocation by factor of 3. This scrap was not discarded but recycled, melted down, and returned to material supply. But the fact that single-facility scrap exceeded entire nations' monthly allocation revealed production capacity disparity that technology could not bridge. Japan lacked aluminum production capacity to support competitive radar development regardless of technical knowledge. Discarded ammunition in testing exceeded enemy combat allocation by staggering amounts. The Western Electric facility tested radar systems by installing them on destroyers conducting live-fire exercises. Each destroyer fired approximately 247 5-inch shells during radar calibration exercises. This represented testing ammunition only, not combat ammunition. Japanese destroyers allocated 185-inch shells monthly for all operations including combat. American testing ammunition for single destroyer exceeded Japanese monthly combat allocation. This single comparison revealed industrial warfare reality. America could expend more ammunition testing equipment than Japan could allocate to combat operations. The mathematics were simple. Abundance defeated scarcity regardless of tactical skill. Captain Tanaka compiled production statistics that headquarters could not dismiss. In October 1943, American radar production was 7,247 units across all types. Our production was 43 units. Their single largest facility produced 2,847 units. Our entire nation produced 43 units. They have installed radar on 287 destroyers, 107 cruisers, and 37 battleships. We have installed radar on 34 destroyers, 12 cruisers, and 4 battleships. Their radar detection range exceeds ours by factor of 3. Their radar-directed fire control exceeds our capability by factor we cannot measure. Admiral, this is not technology gap. This is industrial capacity gap. They produce more in single day than we produce in 2 months. They discard more in waste than we allocate to production. They test equipment with more ammunition than we allocate to combat. This single capacity difference exceeds all our technological developments combined. Every paragraph of production analysis confirmed the same conclusion. American industrial capacity had created technological superiority that Japanese forces could not counter. A single American facility exceeded entire Japanese national production. American waste exceeded Japanese allocation. American testing exceeded Japanese combat operations. The mathematics were irrefutable. What remained was final demonstration that would force even the most optimistic Japanese commanders to acknowledge reality. That demonstration would come at Cape St. George on November 25, 1943, when American radar-directed gunnery would destroy 3 destroyers in 13 minutes with such overwhelming efficiency that denial would no longer be possible. Cape St. George, the final proof. November 25, 1943, Cape St. George, Solomon Islands. 5 Japanese destroyers faced 5 American destroyers in the final demonstration of radar superiority. The engagement lasted 13 minutes. Commander Kyoto Kagawa commanded the Japanese force, consisting of Anami, Makinami, and Ujiri, conducting supply operations to Buka. Captain Arleigh Burke commanded the American force of 5 Fletcher-class destroyers equipped with SG radar and Mk-37 fire control systems. At 01:41 hours, American destroyers achieved radar contact at 22,000 yards. At 01:56 hours, American destroyers achieved firing position and opened coordinated fire at 5,500 yards. At 01:58 hours, Anami was hit by 23 5-inch shells in 90 seconds and exploded. At 02:03 hours, Makinami suffered multiple hits and began sinking. At 02:09 hours, Ujiri was struck by torpedo and destroyed. Ujiri attempted escape, but was pursued and destroyed by radar-directed gunfire. At 01:58 hours, Anami destroyed. Elapsed time from engagement to destruction, 127 seconds. Kill time, 127 seconds. At 02:03 hours, Makinami destroyed. Elapsed time from engagement to destruction, 427 seconds. Kill time, 427 seconds. At 02:09 hours, Ujiri destroyed. Elapsed time from engagement to destruction, 787 seconds. Kill time, 787 seconds. The 3 destroyers were destroyed in 13 minutes by enemies they never successfully engaged. Enemy destroyers destroyed. 3 American losses, 0 casualties, 0 damage. Kill ratio, 3:0. The ammunition expended exceeded Japanese monthly allocation by factor of 4. American destroyers fired 2,705-inch shells in 13 minutes. Japanese Southeast Area Fleet allocated 2,405-inch shells monthly across 20 destroyers for all operations. The single engagement consumed more ammunition than Japan allocated monthly to an entire fleet. The fuel consumed in this engagement exceeded Japanese weekly allocation. American destroyers burned 47,000 gallons of fuel during the pursuit and engagement. Japanese destroyers allocated 38,000 gallons weekly for all patrol, supply, and combat operations. This single aspect of the engagement, fuel expenditure without conservation, revealed industrial capacity gap that tactical skill could not bridge. At 01:58 hours, Rear Admiral Takeo Kurita was aboard the destroyer Anami observing what he believed would demonstrate renewed Japanese night combat capability. He had insisted on personally observing operations to verify that proper tactics could overcome American radar advantages. At 01:58 hours, Anami was struck by concentrated fire from 3 American destroyers delivering coordinated salvos. Kurita was killed instantly when a 5-inch shell penetrated the bridge. Elapsed time from engagement to death, 127 seconds. The admiral who had dismissed American radar technology as insufficient for night combat superiority died in the first minutes of engagement, killed by the very technology he had declared inadequate. His death symbolized the institutional denial that had cost the Imperial Japanese Navy hundreds of sailors and numerous ships. Commander Hara, observing from another destroyer that escaped, later testified, "This wasn't combat. This was systematic annihilation. The Americans detected our force at ranges where we had no awareness of their presence. They achieved firing solutions and coordinated their attack before we saw them. Their first salvos were accurate, striking Anami with multiple hits that destroyed fire control and communications. They maintained perfect formation throughout the engagement, each destroyer contributing to concentrated fire that overwhelmed individual targets. They pursued Ujiri for 8 minutes, maintaining radar contact and delivering accurate fire throughout the pursuit. We never achieved effective return fire. We never forced them to maneuver defensively. We were targets, not combatants. Technology had created capability that rendered warrior spirit irrelevant." The tactical analysis revealed systematic superiority across all engagement phases. American destroyers detected Japanese forces first, achieving 15-minute advantage in tactical awareness. They maneuvered to optimal firing position while Japanese forces continued on course, unaware of American presence. They achieved firing solutions before Japanese lookouts detected them, gaining critical initiative. They opened coordinated fire with 3 destroyers concentrating on single target, ensuring rapid destruction. They maintained formation through radar positioning, eliminating communication requirements that might reveal position. They pursued survivors with radar tracking, preventing escape. Every phase demonstrated technological advantage that Japanese forces could not counter with existing equipment or tactics. The casualty figures revealed the engagement's one-sided nature. Japanese casualties, 1,047 sailors killed, 89 wounded and captured. American casualties, 0 killed, 0 wounded. The mathematical ratio was infinite, total Japanese losses with 0 American losses. This represented not merely victory but capability disparity so profound that the engagement could not be called combat. Japanese destroyers were destroyed by enemies they never saw, using weapons they could not counter, supported by industrial capacity they could not match. The engagement lasted 13 minutes. Planning, detecting, positioning, firing, destroying, all executed with efficiency that left no possibility for Japanese tactical response. Captain Arleigh Burke's after-action report noted the clinical efficiency. Radar contact achieved at 22,000 yards, tracking maintained throughout approach. Firing solution achieved before visual contact, first salvos on target. Anami destroyed in 90 seconds. Makinami destroyed in 7 minutes. Ujiri pursued and destroyed in 13 minutes total engagement time. 0 American casualties. 0 American damage. Ammunition expenditure, 2,705-inch shells. Recommended changes, none. Engagement demonstrates complete effectiveness of radar-directed night combat tactics against forces without equivalent capability. The report's matter-of-fact tone revealed how thoroughly American forces had integrated radar into operations. This was not experimental technology requiring special conditions. This was standard combat procedure that worked reliably under all conditions against enemies lacking equivalent systems. Cape St. George ended Japanese night combat superiority permanently. 3 destroyers destroyed in 13 minutes with 0 American casualties proved that radar had revolutionized naval warfare. Japanese tactics that had dominated night combat for 18 months were obsolete. Japanese warrior spirit and superior training were irrelevant against enemies who could see in darkness, while Japanese forces remained blind. The mathematics were final. American radar superiority multiplied by industrial capacity equaled systematic defeat for Japanese forces. What remained was testimony from survivors explaining how industrial capacity had overcome tactical skill through technological superiority, so profound it could not be countered without equivalent industrial base. Testimonies of defeat, understanding industrial warfare. December 1943, Allied prisoner of war interrogation center, Guadalcanal. Captain Reizo Tanaka, captured after his destroyer was sunk at Cape St. George, provided comprehensive testimony that Allied intelligence officers found remarkable for its analytical clarity. We were not defeated by better soldiers, but by better factories. American radar production in October 1943 was 7,247 units. Our production was 43 units. Their single largest facility produced 2,847 units monthly. Our entire nation produced 43 units monthly. A single American factory produced more than our entire empire. This was not technology failure. This was industrial capacity failure. We could have developed equivalent radar systems given time and resources, but we lacked industrial base to produce systems at scale. American advantage was not technical knowledge, but production capacity applied to technological development. Commander Tamaki Hara, the sole survivor from Shigyur at Vela Gulf, provided testimony connecting technological and tactical evolution. I saw American destroyers destroy 3 ships in 6 minutes at Vela Gulf. I witnessed cruisers firing with impossible accuracy in darkness at Empress Augusta Bay. At Cape St. George, I observed systematic annihilation of forces that never achieved effective combat. The Americans did not just produce us. They revolutionized production itself. They created manufacturing processes that produced radar systems faster than we could produce destroyers. They established quality control that ensured reliability we could not match. They deployed systems at scale that made our limited radar installations irrelevant. Most critically, they integrated radar into doctrine, training every officer and sailor to use electronic systems as naturally as visual sighting. This was not technology adoption. This was warfare transformation, driven by industrial capacity. Lieutenant Masaru Nakagawa, fire control officer from Anami, provided the most painful testimony, describing the final moments of Rear Admiral Kurita. The admiral insisted our warrior spirit would overcome American technology. He believed superior tactics and training would prevail. He died in the first minute of combat, killed by enemies he never saw. His last words were orders to commence visual search for American forces. Those forces were already firing on us with radar-directed accuracy. He died believing our doctrine was sound. He died wrong. Technology had made our methods obsolete, and we refused to accept this until too late. Testimonies revealed a consistent theme. The war had become contest between industrial systems rather than military forces. We brought swords to gunfights, one officer stated, not because we were stupid, but because we lacked factories to produce guns at scale. Another testimony noted, their excess capacity exceeded our maximum effort. They could lose 10 ships and replace them in 2 weeks. We could lose 1 ship and required 6 months to replace. This arithmetic meant we were losing before combat started. A third officer observed, they could lose 10,000 men and barely notice. We lost 1,000 and faced crisis. Their industrial capacity absorbed losses we could not sustain. Every testimony reached the same conclusion. Industrial capacity, not tactical skill or warrior spirit, determined victory. Production statistics stated by captured officers revealed how thoroughly they understood defeat's source. American production, 7,247 radar units monthly. Japanese production, 43 units monthly. Single American factory, 2,847 units monthly. Entire Japanese empire, 43 units monthly. American destroyer production, 11 hulls monthly. Japanese production, 2 hulls monthly. American cruiser production, 7 hulls monthly. Japanese production, 0.4 hulls monthly. The statistics continued through every category: aircraft, submarines, ammunition, fuel, food, everything necessary for sustained warfare. Every metric revealed the same pattern. American production exceeded Japanese production by factors of 5 to 100 depending on item. The cumulative effect was industrial tsunami that Japanese forces could not resist regardless of tactical skill or courage. Captain Tanaka provided the most comprehensive strategic analysis, explaining how American industrial capacity had transformed warfare itself. Wars are no longer won by generals but by factory managers. Victory belongs not to the bravest soldiers but to nations with most productive economies. The Americans demonstrated this principle completely. They produced more radar in single month than we produced in entire war. They installed radar on hundreds of ships while we installed it on dozens. They trained thousands of radar operators while we trained hundreds. They integrated radar into doctrine while we treated it as auxiliary equipment. Most importantly, they did all this while simultaneously fighting in Europe, supporting British and Soviet forces, maintaining defensive positions across the Pacific, and conducting strategic bombing campaigns. Their industrial capacity supported warfare on global scale, while we struggled to maintain operations in single theater. Allied intelligence officers found these testimonies valuable not for tactical details, but for strategic insights they provided into Japanese understanding of industrial warfare. One report noted, "Captured officers demonstrate clear understanding that they lost not because their tactics failed, but because their industrial base could not support competitive warfare. They recognize American radar superiority resulted from production capacity rather than technical knowledge. They understand that superior training and warrior spirit are irrelevant against overwhelming material superiority. Most significantly, they acknowledge that Japanese industrial capacity could never have supported victory regardless of tactical skill or strategic planning. This represented complete intellectual capitulation. Recognition that the war had been unwinnable from industrial capacity, perspective regardless of military factors." Commander Hara's final testimony summarized the transformation from confidence to defeat. "In October 1942, we believed our night combat superiority would control the Solomon Islands. In August 1943, after Vela Gulf, we understood Americans had developed capabilities we could not counter. In November 1943, after Cape St. George, we recognized that industrial capacity had created technological superiority that made our methods obsolete. We had been fighting 20th century war with 19th century capacity. The Americans fought with 21st century capacity. The gap was unbridgeable without industrial transformation we could not achieve during wartime. We lost not because we fought badly, but because we lacked factories to fight well." The testimonies revealed understanding that transcended military defeat. Captured officers recognized they had witnessed transformation in warfare itself, where industrial capacity became decisive factor, overriding all tactical considerations. They understood that future wars would be won by nations with productive economies rather than brave soldiers. They acknowledged that technological superiority derived from industrial base rather than scientific knowledge. Most painfully, they recognized that Japanese warrior spirit and superior training had been rendered irrelevant by enemies who could see in darkness, hit targets without visual contact, and expend ammunition without conservation, because factories replaced expended materials faster than combat consumed them. This was defeat not of Japanese military, but of Japanese industrial capacity. The testimonies made this clear. The democratic arsenal, industrial warfare's final lesson. The radar revolution proved that democratic industrial capacity defeats authoritarian military excellence. Free workers outproduced slaves. Democratic cooperation exceeded totalitarian command. Industrial abundance buried ideological superiority under measurable quantities. 7,247 radar units monthly versus 43. Helen Morrison in Des Moines, Robert Washington in Birmingham, Charles Wilson from General Electric. These civilian workers produced more military capacity than entire Japanese empire, because free societies mobilize industrial capacity more effectively than authoritarian regimes. The Massachusetts Institute of Technology's Radiation Laboratory employed 3,847 personnel developing radar. Japanese radar programs employed 189. This ratio reflected fundamental principle. Democratic societies generate innovation through collaboration, while authoritarian societies stifle innovation through control. American radar superiority resulted not from superior scientists, but from superior system that enabled scientists to work effectively. The production comparisons revealed democracy's industrial advantage. American factories produced radar at rates Japan could not match because American workers were educated, well-fed, properly equipped, and motivated by compensation rather than coercion. Japanese workers were malnourished, inadequately trained, poorly equipped, and driven by ideology rather than incentive. American production exceeded Japanese production because democracy created conditions where industrial capacity flourished, while authoritarianism created conditions where industrial capacity withered. This was not accident. This was inevitable consequence of political systems. Democracy optimizes industrial capacity, while authoritarianism constrains it. October 15, 1943. Rear Admiral Takeo Kurita had laughed at American radar technology. November 25, 1943. He died in the first minute of combat, killed by the technology he dismissed. His mockery became history's most catastrophic miscalculation. The Cape St. George engagement demonstrated that technological superiority multiplied by industrial capacity creates military capability that courage cannot overcome. 3 destroyers destroyed in 13 minutes. 1,047 sailors killed. 0 American casualties. The mathematics were final. American industrial capacity had produced radar systems that revolutionized naval warfare. Japanese warrior spirit and superior training were irrelevant against enemies who possessed technological superiority supported by industrial abundance. The lesson remains: dismissing democratic nations as weak because they prefer peace or underestimating free people's productive capacity invites catastrophic miscalculation. Industrial capacity, not military excellence, determines victory in modern warfare. Nations that fail to understand this principle face defeat regardless of tactical skill, strategic planning, or soldier courage. The radar revolution proved this conclusively.